All right, section 2.6 is about finding the domains of functions. Okay, we've talked about this a little bit, but now we're going to really go in depth with it. Okay, so you're going to have three cases, right? Three cases that are going to tell you about the domain of the function that you're given. Okay, case one is your denominator. Okay, so say I give you a function and it has an x in the denominator or something like that. You must exclude the numbers which make the denominator equal to 0. Okay, so why? Why would I say that? Because whenever we have anything over 0, right, anything over 0, we say that that is undefined. Okay, that's a problem. Okay, undefined is an issue. And so we want to exclude all the numbers that would make our denominator undefined, which would mean equal to 0. Okay, so your procedure is to set your denominator equal to 0 and exclude those numbers. Okay, case two is an even radical. Okay, numbers which produce a negative radicand must be excluded from the domain. Okay, so this means when I say even radical, this means, whoops, the square root, fourth root, sixth root, okay, and so on. Okay, that's what I mean when I say even root. We have an issue whenever we have an even root and we're taking the negative root of it. We're taking the negative even root, so we have -4 under here. We have an issue. Okay, we know about the letter I, right? Which is the square root of -1, but we still don't have a real answer. We have a complex answer whenever we do that. So if you have an even radical and you need to make sure that you're excluding all the numbers that make your radicand, so everything under the radical negative, you are going to set your radicand equal to, greater than or equal to 0. Okay, so your radicand will be what's ever in here. Okay, so if you had x plus 3 inside here, you would set x plus 3 greater than or equal to 0. And what you would find is all of the numbers that make your radicand positive. Okay, you will find the interval of numbers that make all of your radicands positive. Okay, case three is all other cases. Okay, this is all real numbers. This is when you don't have a fraction and when you don't have a root, an even root. Okay, if you have an odd root, you are fine. We can have negative numbers as our radicand with odd radicals. It only matters when it's an even radical. Okay, so if you had an odd radical, if you just had an expression there, you would just say, okay, all real numbers. That means that whatever I plug in as x, I'm going to get a number out. Okay, I plug something in, I get something out. We're excluding from these two the cases where we plug something in and we don't get anything out. Okay, that's what we're excluding from these. This case says I can plug in from negative infinity to infinity and I'll get a number back. Okay, so those are the three cases. So let's do some examples. Find the domain of the functions, write your answers in interval notation. Okay, so the first one is f of x equals x squared minus 9. Okay, case one deals with fractions. Case two deals with roots. Case three is all other cases. So this will be case three, right? This doesn't have anything to do with a fraction or a radical. So we can plug in any number that we want for x and we'll get a number back out. Okay, so the domain would be all real numbers or negative infinity to infinity in interval notation. All right, the second one, we have g of x equals 5 over x minus 3. Okay, this would be case 1, right? It's dealing with a fraction. So you set denominator equal to 0 and exclude. Okay, denominator equal to 0, solve for x, and x equals 3. So what this means is that whenever x is 3, we get 0 for our denominator, and that's an issue. Okay, so we want x to never equal 3. It can equal any other number that it would like to equal, but it cannot equal 3. Okay, so on a number line, we need to put this in interval notation. So let's say 3 is right here, and here's infinity, and here's negative infinity. So I'm saying that it cannot be this number, but it can be all of these numbers, and it can be all the numbers on the other side of it. Okay, so I'm saying that it can go from negative infinity to 3 with a parentheses on it, because that means that 3 is not included, which would be right. Union 3 all the way to positive infinity. So all I did was put this in interval notation where it excluded just 3. And that's how you do that. Okay. By putting a parentheses here and here and unioning it together. I don't know if that's a word, but doing the union and putting parentheses here, you're just excluding 3, and you're saying I can be all the numbers on the other side of 3 and on the right side of 3. Okay. All right, well, look at this one. You have k of x equal to x plus 11 over x squared minus 4x minus 21. Okay, so this would be case 2. It's the fraction one, right? So we're going to set our denominator equal to 0 and solve. All right, this is a trinomial equal to 0, so we're going to factor it. We have x and x. This would be an easy trinomial. Our signs are different because of our negative right there. So we're going to have a plus and a minus. And we need the factors of 21 that add to give us negative 4. So that's going to be negative 7 and 3. Okay, so now we need to apply the zero product rule. So we're going to say x plus 3 equals 0, x minus 7 equals 0. Subtract 3 and get x equals negative 3. Add 7. Get x equals 7. Okay, so here's what I'm saying. X cannot be negative 3 and it cannot be 7. If it is negative 3 or 7, you get 0 as your denominator, and that's an issue. Okay, so let's put it on a number line and see how we're going to put it in interval notation. Here is negative 3. Here is 7. And it cannot be those two numbers, but it can be everything else. Okay. It can be that, it can be this, or it can be any of these numbers. Okay. So we just need to put that in interval notation. So it would be, your first interval would be negative infinity to negative 3 with the parentheses. You would union that with negative 3 to 7. That's your middle interval. Then you would union that with 7, infinity. Okay, just use parentheses on all of them so that you're excluding negative 3 and 7. But you can get really, really close to 3, negative 3 and 7, but you just can't be at -3 and 7. Okay. Let's do some with radicals. So we have h of x equals the square root of x plus 5. Okay. Remember, we have an issue. This would be case 2. I should have written case 1 on that one. Sorry. This would be case 2. Deals with even radicals, right? And I set the radicand, which is what's under the radical, greater than or equal to 0. And then I solve. And I get x is greater than or equal to -5. Okay. So what does this mean? This means that as long as x is greater than or equal to -5, I'm going to be positive. Those are the numbers that I want. I want x to be greater than or equal to -5, because that way what's ever under here will be positive. Okay, which makes sense, right? If I plugged in -5, I would get 0, which is fine. But if I plugged in -6, I would get the square root of -1, which is an issue. Okay, so I need to put x is greater than or equal to -5. Okay, the equal to sign tells me bracket, right? So I'm going to have bracket 5 all the way -5, sorry, to infinity. Because as long as I'm greater than or equal to -5, I'm good. All right, let's look at this one. M of x equals the cubed root of x plus 1. Okay, your first thought may be to set x plus 1 greater than or equal to 0, and I would say that you are not right, because this is an odd radical. I only have an issue with even radicals, right? This is even radical. This was the cubed root. I have an issue with that, but I can plug in any number I want for x and I'll get a number back out for this one. Okay, so this one's an odd radical. So this would be case 3. And I can plug in any numbers I want. So I'm going to say -infinity to infinity. Okay. So the big point here is this page. Okay. As long as you remember case 1 is denominator. So you're going to set your denominator equal to 0 and exclude all of those numbers. Even radical means that you'll set your radicand greater than or equal to 0. And then all other cases. So if you don't have a fraction or you don't have an even radical, you're going to put -infinity to infinity. So all real numbers you could plug in. Okay. Okay, so also in this section, we have combining functions. Okay, and there's 4 ways that we can do that. We can add, subtract, multiply, and divide, of course, all of these functions. So basically, all this section says, all this part says is if I'm adding 2 functions, if I want to find f plus g of x, then I just find f of x plus g of x. Same thing with subtraction and multiplication and division. Okay, you're just going to split them up and do the operation. Okay, so if f of x is x minus 5 and g of x is x squared minus 1, then we can find f minus g of x, f times g of x, f divided by g of x. So let's find f minus g of x. So we can say f of x minus g of x. Okay, that's what our rules just told us. And so we get f of x is x minus 5 minus g of x is x squared minus 1. So we have x minus 5, and then we need to distribute this negative. and get negative x squared plus 1. Then we have some like terms with negative 5 and 1. So we get negative x squared plus x minus 4. Okay, we can also multiply these, so we can get f of x times g of x. So we would have x minus 5 times x squared minus 1. Okay, well, that's a binomial times a binomial, so we will FOIL that. So we'll do first, outside, inside, last. So x times x squared is x cubed. And then we would do x times negative 1 is negative 1x. Negative 5 times x squared is negative 5x squared. And negative 5 times negative 1 is positive 5. Okay, we can flip the order around, put them in descending order. X cubed minus 5x squared minus x plus 5. Okay, we can also divide them, and we would do f of x over g of x. F of x is x minus 5. G of x is x squared minus 1. And that is all you can do to that. No more simplification, so you're just left with x minus 5 over x squared minus 1. Last one, we can do f plus g of 2. Okay, so we're going to plug in 2 for x. Okay, so but first, let's see what f plus g of x would be. We would have x minus 5 plus x squared minus 1, which would give us x minus 5 plus x squared minus 1. We can add those like terms and get x squared plus x minus 6. Now we need to plug in 2 from over here. So we get 2 squared plus 2 minus 6. Okay, well, that's 4 plus 2, which is 6. Minus 6 is 0. So we would get 0 as our answer. Okay, that was just applying those 4 rules. Okay. Now, let's do something like this. F of x is x squared minus 3. G of x is 4x plus 1. Okay. So we would have f of x minus g of x. So we have x squared minus 3 minus 4x plus 1. Distribute that negative 3. X squared minus 3 minus 4x minus 1 gives us x squared minus 4x minus 4. Okay. Now let's do f of g of 4. So we're going to multiply f and g. Multiply f and g, and then plug in 4. Okay, so that was this part. So let's multiply f and g. So we'll get x squared minus 3 times 4x plus 1. So we're just going to FOIL that and get 4x cubed plus x squared minus 12x minus 3. Okay, so that is f times g of x. Now we're going to plug in 4. Okay, and I'll change the color to purple to match the other one. So we'll do 4 times 4 cubed plus 4 squared minus 12 times 4 minus 3. Okay, so you're going to do 4 cubed first and get 64 plus 16 minus 48 minus 3. 4 times 64 is 256 plus 16 minus 48 minus 3, and you get 221. You have a calculator, so you could use it there. Okay. So that is using those 4 rules of combining functions. We also have something called the composition of 2 functions, f and g. So this is saying f of g of x, okay? F of g of x. This sign right here is the symbol for composition. Okay? It is not to multiply. That does not say f times g. Okay? It's f of g of x, okay? So it looks like this, f of g of x. So what this means is that wherever there is an x in f, you're going to plug in g of x. Okay, so f of g of x. So you have f of g of x. Here's your f of x and your g of x. F of x is 5x plus 6. G of x is x squared minus 1. Okay, so your shell is going to be f. So you're going to have 5, and then wherever there's an x in your f, you're just going to leave parentheses and finish out your f of x, okay? You will put g of x wherever you have a set of parentheses, okay? So you have 5 times g of x is x squared minus 1 plus 6. So you get 5x squared minus 5 plus 6. So you get 5x squared plus 1. Okay. So whatever is on the outside is your shell. So you're going to leave wherever your x's were, you're going to leave those parentheses blank, and then you'll plug in whatever your other function was. So here we have g of f of x. So now we have g on the outside and f of x on the inside. So now g of x will be your shell. So you have x squared minus 1, and you plug in f of x into your parentheses. So you have 5x plus 6 squared minus 1. Okay, 5x plus 6 is 5x plus 6 squared looks like this. So you're going to FOIL it. And you get 25x squared plus 30x plus 30x plus 36 minus 1. I'm going to change this color to blue so you can see where I stopped foiling, right? I still had to account for my minus 1. Don't forget that. Let's add like terms. 25x squared plus 60x plus 35. Okay. Our like terms were here to here. Okay, that is the composition of 2 functions. So f of g of x and g of f of x. Okay.